this one. So what do we know about limits with infinity? Infinite limits. So today we're learning to determine infinite limits and asymptotes. We'll be successful when we can determine asymptotes using a variety of strategies. All right. So infinite limits. In pretty much every situation, in most situations, infinite limits are asymptotes. We generally like to use them interchangeably, but they're not always interchangeable. But often, for a lot of the things we will deal with, an infinite limit and an asymptote are, for the most part, the same thing. It's just like how we describe what's going on. Again, the asymptote is all about that limit idea as you approach a value. And the reason I'm saying that asymptotes and infinite limits are fairly interchangeable, because as x goes to infinity or y goes, or like the output goes to infinity, usually that means we have an asymptote going on, or there's like some end behavior that we're trying to describe, and that's really talking about asymptotes. So we'll take a moment to look at that. So the types of asymptotes, there's three kinds of asymptotes. Look at that. There's horizontal asymptotes, vertical asymptotes, and the third one we're the least familiar with that we touched briefly on in pre-calc, slant asymptotes, also called oblique asymptotes. So there is not whiteboards for these examples, but horizontal asymptotes. These are about what happens when x is really big, either in the positive or negative direction. So the important thing with the horizontal asymptote that's different from, or the thing that's indicative of it, is that x is approaching infinity, or x is approaching negative infinity for some function, and that function approaches a finite number. That's the key thing here, is that it's approaching a finite number. All right. When you have a limit statement like this, we can say there's an asymptote at y equals L. A horizontal asymptote at y equals L. Again, maybe you reach L, maybe you don't. Maybe you touch it once and that's done, or maybe you touch it an infinite number of times. But it's still the asymptote. They're super easy for rational functions containing only polynomials. In chapter 2, we're going to learn about L'Hopital's rule. That'll make that easier. But for now, we're just going to kind of look at the leading terms, which more or less is L'Hopital's rule anyways. If you remember, at the end of the year last year, we did a couple of different ways that we did stuff like this. We did that via polynomial division. We divided everything by the dominant term, with at the dominant term the numerator and denominator, and looked and see where things were. If the dominant thing was in the bottom, we're like, oh, it's going to go to 0 because the bottom grows faster. If it's in the top, it's going to go off to infinity. So that's kind of that. That's kind of how those different horizontal asymptotes work. And there's a bunch more things that we can do with that. Again, some more examples. You'll see these as you read through this section if you haven't done so already. All right. The next kind of asymptote we talked about are vertical asymptotes. And when we deal with vertical asymptotes, again, you're typically seeing the limit as x approaches some constant, some finite number from the left or the right of f of x, and it goes to positive or negative infinity. They also happen when you get a non-zero quantity divided by 0. They don't exist, even if we write one-side limits for them. So a correct answer for this is either the way it's written up here, over here, or it either does not exist or positive infinity. Either one is just fine. All right? So you can decide that and kind of think about what you're doing. But if you have a vertical asymptote and you say the limit doesn't exist, or you say it goes to positive infinity, those are both correct statements. Probably the best thing you could write is here. Let me take off the pointer. Oh, nope. Oh, I have the thing. I know what the thing is. Let's annotate. So want to do it? Oh, okay. You could also write D and E. Can you see me writing, folks?
Yes.
Sweet. Thank you. I just wanted to make sure that it was visible. Because my setup changed, for whatever reason, the setup changed and it's not displaying on the correct screen anymore. But you could say D&E but approaches like positive infinity. So you could do it like that. So D&E but approaches positive infinity. That's probably the best way to answer those. But does not exist or positive infinity or negative infinity also all work. All right. Turn annotate off and leave that there for the moment. In the previous lesson, we looked a little bit about discontinuities. Something to note about vertical asymptotes when you're analytically working with things is that when you plug it in, you get that non-zero term divided by a zero term, which means something divided by nothing is going to give you a vertical asymptote. And that makes more and more sense if you think about, well, I have one thing. What if I break it into two how many halves would one thing break into? 2. How many thirds would it break into? 3. And as you make that number smaller and smaller and smaller, you're taking one object and breaking into so many more pieces. So if you're looking at dividing like 1 by a millionth, you would have a million pieces, which is why that gets so big. And if that number gets smaller and smaller and smaller, you're like, well, I want to break this one object into this many pieces. When you get to 0, basically you're saying this one thing just blows up. But holes generally happen when you get 0 divided by 0. Again, you still need to look and check some other things because we see that absolute value of x over x is one of those, is like the exception here. We always have to remember that. All right, let's clear that annotation. Clear my drawings. All right. The last one that we won't spend tons of time on, but we still use every now and then are slant asymptotes. We talked about these in pre-calc as oblique asymptotes, but slant, oblique, they're like the same thing. It doesn't really make a big difference. But here's generally what they look like and kind of how we get them. So I got this blue equation, as it says, by doing polynomial division on this equation. Oh, hold on, pointer. That would be helpful. I use polynomial division on this problem to get this. Notice I got a remainder over here. That's also why there's a vertical asymptote at x equals 1 here. But the thing to note that the horizontal or the oblique asymptote or the slant asymptote here is this negative 3x minus 3. It's the part that's not the remainder. This is the slant asymptote here. So we could say for this, and we kind of did a little bit of this in pre-calc, but we're not going to do tons of it this year, is you could say as x approaches positive infinity, y approaches negative infinity as negative 3x minus 3. That doesn't really help for a lot of things we do right now. There are some applications and some other circles and things, but it's not really something that we're going to spend tons of time on. I just want to point that out to say, like, there's more specific ways we can say x goes to infinity, y goes to infinity. And if you really think about it, horizontal asymptotes are a special case of slant asymptotes. Like we, instead of having like a variable here, when you get a horizontal asymptote, it's usually like 3 plus a remainder or something like that. I already mentioned that. That's what I have for you today, folks. I just want to really make sure I emphasized these different things. The 3 different kinds of asymptotes, and that they all deal with infinity in some way. Let's see, I could probably type on here. Yeah, I can. So let me type out what I was saying on this. I could say, as x approaches infinity, y I spelled it wrong. Approaches, let's just write it out, negative infinity as negative 3x minus 3. That's a 3. That's a way I could describe the infinite end behavior here with a little more direction. And then we could say that for the same thing going to the negative direction. Teddy's having Wi-Fi troubles. That makes sense why he's not in here. All righty. That's generally what I have for you today. Chapter 1, especially 1.4 and 1.5, don't have a lot to talk about and share. It's just kind of talking about some different things. And then as you have questions, you can post things in Discord or email me, do whatevs. I'd rather you do it in Discord because if you have the question, other people might have the question too. I know I talked to 1 or 2 of you about 89 individually on section 1.3, and someone from Mr. Weimer's class, I think it was Abby, had the courage to post a question about it in the public chat or in the AB channel, which allowed all of us to kind of have like, oh, okay, that's a thing. So I'm not the only one with a question on that one. I expect you to kind of have questions on some of those. Some of the questions aren't meant for you to completely do on your own, that you're going to ask a question about. So we intentionally pick ones that will be difficult sometimes. So if you haven't been doing it, I would try to touch base with someone else from class, either our class or Mr. Weimer's class, so that you're not working on these completely by yourself. The first couple assignments, probably okay. There's nothing like super wild or crazy in them, except like 89. But I would try to find 1, 2 other people, maybe Zoom in with them later in the day to chat about a couple problems, see what they got, check answers, approaches. Because again, that collaboration that we do all the time in the classroom, we don't get in this environment as much. So I want to make sure we point that out and have the opportunity to play with that. Let me clear my annotation there. All right, there it is. I don't think I have any memes afterwards. No, this is a very meme-less thing. That's tragic. But there's the 1.5. I think I have that assignment up in Schoology. If I don't, I'm going to go put it up there right now. But before I end the meeting, any general questions that you'd like to ask? Oh, I got to talk about Friday. Okay. So Friday, there's a little quiz that we're going to do. Because Mr. Weimer and I were looking at the calendar and realized, oh, it's getting into week 3. We should probably get something else in the grade book other than formative stuff. And it's an opportunity to use AP Classroom, make sure everyone's signed up for it. Again, you don't have to sign up for the test just yet. You have until November 2nd. I think it's November 2nd to sign up, to make your decision. Again, be thoughtful because there's a lot of time after that before the AP test. So I would consider signing up for it. I would recommend that all of you sign up for it, even if you decided not to take it later on. It's easier to make that decision than to try to go the other way around because it won't happen. So yeah, that's kind of what I have for you. But you have a 10-question multiple choice quiz that you're going to get on AP Classroom, and basically, from what I was thinking, that our support time, our Zoom time during that, will be basically making sure that you can get in and do stuff. We won't be necessarily asking questions, but I just want to make sure that you can navigate AP Classroom. You've found out where the assignments were and all that jazz. Yeah, that's all I really have for you. If you have any further questions, you can say in the Zoom. Otherwise, keep working on 1.4 and 1.5. Make sure you read through both of them, because while I can talk and show you things, sometimes it's good to make sure you read the book as well, especially when the book is a reference object rather than something we learn from. I want to make sure that you're taking that opportunity to read and see what's there. So if you have any further questions, you can stay on. Otherwise, see you later, folks.